Also, just overview on today. So you all took the practice final. We're going to review the answers now, go over final exam logistics and like remaining assignments, and then my final thoughts, because this is essentially our last lecture, and people will be finishing the finals at different times. So this is kind of my chance to do final goodbyes and last thoughts. Okay, code that repeats unknown number of times. You all said while loop. Sounds good. Used to compare the efficiency of different code blocks. Big O notation. So what is big O notation? Like, if we had to describe it. Runtime analysis, essentially, how many lines of code are going to run in our program in the best case or the worst case? In the worst case. So a lot of algorithms, if like a sorting algorithm, if it was already fully sorted, in the best case, you wouldn't really have to run any code. And so it's not really meaningful to share those values there. Here, wait, Matthew, EJ. Cool. And then last one, we've seen a bunch. Uniquely named storage location that holds one piece of data. Variable. All right, the others that we didn't get to here, parallel array. When are those generally used? What kinds of problems? Yeah. Essentially, like we have multiple different arrays, but each index, there's a relationship between them. Okay, struct. When would we use a struct? So very similar to an array, but if the data types are different, then we have to use a struct. If, else statement, when might we use that? Conditions, so if our code is going to do different things based on a given condition. Cool. Any questions here? Okay. Debug my code. This time we have something with functions, so we have void print welcome. We call it in the main here. What's the first mistake? Line 4. What's wrong with line 4? Yeah, so when we define a function, what do we need to do for the parameters? We need to say, yeah, what the data types are. So in this case, well, if we were to fix it, how could we fix this line of code? You put string name. Cool. So when defining a function, data types needed for each parameter, you can change it to void print welcome string name. All right, what's the next error? What's wrong with line 6? Yep, because we said the return. Right now, name is what data type? String. But we said we're not going to return anything, like no data type. So the computer is going to error when it's like trying to return a string, even though we said it's a void function that doesn't return anything. So to fix it, we can just delete line 6. Void functions don't need a return statement. Okay? Okay. And so we know print welcome is a void function. Knowing that, what is the last error? Yeah, so 10 and 11, specifically on 11, what's the issue?
Results are double and it's equal to a string.
And well, in a sense, print welcome, we're saying it's void. So print welcome is, like, there is no data type. So the computer's going to error here because print welcome doesn't return anything. So even if this was like string result, this would still error because it's a void function, so there's just no return value. If we were to fix it, it would just be like remove this result equals, so remove the assignment statement, and just call print welcome. Yeah, question.
You wouldn't do hashtag include string because you're not using the string data type.
Okay, I guess after we fix it, like we would have to say string name, and then I guess you do include string. That's a good point. Like technically, I should have just included string as well, just to be safe. Yeah. All right. Question? Yep.
I said the right thing for a method. I think I was thinking about it differently.
Okay.
I think I was confused because would that even actually? Okay, well, it wouldn't print anything, but it wouldn't print anything because of the void, right? Like would result on 11. Like that wouldn't actually work because the function's void, so there's no data there.
Yeah, it's like normally we'd say like result is equal to 5.3 or something. in this case, like print welcome, just because it doesn't return anything. Like I don't really know how to describe void. It's just like there's nothing.
Yeah.
So we're trying to say like result equals, like it's almost the same thing as saying like result equals and then just a semicolon. Like there's nothing there that's actually returned. So the computer's gonna error. Yeah. Okay. Any other questions? Make sense? Okay. Number 3, array processing. We're trying to make every element in this array positive. Keywords here are like every element. When we see something along these lines of like every element, what should be going off in your head regarding for loops? Yeah, so like what value is index going to start at? 0. What is it going to go up till?
Less than size.
Yeah, less than size. What's the size of the array in this case? 4. So, okay, so index will be less than 4. And then what's the update? Index plus plus. Generally, if we're doing something with every letter in a string or every element in an array, this is generally always going to be the setup, right? Index equals 0, index less than the size, index plus equals 1 or plus plus. One thing with computer science is trying to match problems to problems that we've done in the past. What problem does this remind people of? Like trying to make everything positive.
Absolute value.
Absolute value. Because in absolute value, if the number is already positive, we don't have to do anything. And if it's negative, then we make it positive. So do we have to do anything for the 3 or the 0?
No.
Do we have to do something for the negative 2.4 and the negative 100?
Yes.
Yes. So we're doing 2 different things based on what the number is. That's your, like, again, bell should be going off like, all right, I need an if statement here, because 2 different things are going to happen. In the if statement, we said we only want to run code for the negative 2.4 and the negative 100. So what can we put in our if statement?
If nums of index.
Cool. So if nums of index is less than 0. Again, if we're trying to get every element, nums of index now will give us every element, because the first time the loop runs, nums of 0 will be negative 2.4. Then the next time the loop runs, nums of 1 is going to be equal to 3, nums of 2 will be 0, nums of 3 will be negative 100, and then we'll never get nums of 4 because the for loop will exit before that. Yep. Okay, so if it's less than 0, what do we want to do to nums of index?
Num index times negative 1.
Yeah, so essentially like negative 2.4, if we multiply by negative 1, that will make it 2.4. So nums of index is equal to nums of index times negative 1. Yeah.
I did, for my for loop, I did index is less than array dot size.
So arrays don't have the dot size function. That's partially why we learned about vectors. Like if this was a vector, you could have done nums dot size. But because it's an array, we have to say like the actual number here. Or if this was in a function, I would give you a parameter called like array size. And then you would say less than array size. All right. Any other questions? Make sense? Okay. All right. For this function output, we had 3 different answers that were evenly split in the morning class. I guess if everyone can close their eyes, and I want you to like hold up the answer that you put, just so that I can see where people are at. So everyone close your eyes, and then on your fingers, hold up what you think the answer is. Okay, cool, everyone can put down their fingers. Okay, kind of an even split again between 4, 6, and 10 as the 3 answers. So we have the code visualizer. Let's step through it. There will be a question very similar to this on the final, so please try to follow along. Okay. So this is the same code we had on the exam. We start in the main function. The visualizer can't really visualize vectors, but this would be the values 3, 2, 1. What is the value of sum going to be at this point?
4.
4. At line 16, we call sum vector, so what line is going to run next? Yeah, we're going to jump up to 5. So we see, like, to call a function, you put the name of the function, sum vector, and then note that we didn't have to say vector double nums here, right? When we call a function, we just put in the value. So at this point, we're really just passing in this, like, 3, 2, 1. Okay? So we call the function. At this line, we have another variable called double sum, and we set it equal to 0. does that mean this 4 is going to change to a 0?
No.
No. What's going to happen instead?
Another variable.
Yeah, there's going to be another variable called sum that gets set to 0. How is this possible? I thought we said variables had to be uniquely named. So how is it that we have 2 different variables called sum? Yeah.
Because it's different between function and the main function.
Yes. So this is what we call variable scope. This double sum here only exists between lines 15 and 18. Like it only exists in this main function. This double sum only exists between lines 6 and 10. So they're stored as like 2 different memory location areas. In the main, we couldn't create another double sum equals 0 because it already exists here. But we're able to create it here because it's in an entirely different memory location. Does that make sense? Okay, so in that case, if we want to share data between main and this one, it can't just be based on the variable name. Instead, we have to use parameters and return values. Like that's the whole purpose of parameters and return values is if we actually want to share data, then we have to send it. Okay? Any questions on that first big concept? Make sense? Okay. So when we step through, so sum is initially 0, and we add nums of 0. So what's the value of nums of 0? 3. So the sum in the sum vector function is going to increase to 3. But note that the sum in the main function stays the same. Yep. Okay. Then the next time the loop runs, we add on nums of 1. So what's going to change here? Yeah, we're going to add 2, so it's going to become 5. Then we run again, nums of 2. So what changes in sum? 6. And so now we exit the for loop. What value gets returned? 6 gets returned. So we're going to come back to line 16. You can replace the sum vector of nums with just the number 6, because this returns 6. Okay? But what happens to the 6? Like, are we doing anything with it? Yeah, it's essentially lost. Like, we did all this work. We got the value 6. The code is still going to run. Like, it's just going to say this is 6. But we're not doing anything with it. So we come down here. It returns 6, but we didn't do anything with it. And now, when we see out the sum is, what's going to be printed out? 4. Because we had double sum equals 4. So the answer for this one, the sum is 4. Okay? If we were to modify this code and say here, sum is equal to sum of vector, and we're to step through it a little bit quicker this time. So we code a line 5. We again do the same thing. So sum is 3. Then we add 2. It becomes 5. Then we're about to add 1. It becomes 6. What do we return? 6. So that's the same thing as saying, like, this part right here is 6. So what is going to happen on line 16? Sum is equal to 6. We're assigning a new value to sum in the main function. So right now, sum in the main function is 4. But after line 16 runs, what is it going to change to? 6. And we see that there. The sum changed from 4 to 6. And now, if we were to print out the sum is, what would be printed? The sum is 6. Okay. Questions there? There's 2 big concepts at play here. The first is that you can have the same named variables in different functions because they're treated as completely different memory locations. When I ask you, though, what the output is here, it really is just based on the variables in here. The second big concept to take away with functions is if it returns a value, you generally need to store that value somewhere if you want to continue to use it in main. Otherwise, it's essentially doing the work, but then if we don't assign it to a variable, it essentially gets lost. Okay. One thing we could have even done if you wanted, like if you don't want to store it in a variable, so this is what our code looked like initially, you could also just like see out it immediately. Like in this case, it would then say like the sum is 6. What I want you to take away is like you can just think of this as whatever's returned. So you can assign that to a variable, you can see out it directly. Whatever you could do with a normal like number or something that's returned, you can do with the function return. Is that clear? Okay. But if it's like this and it gets a value and you don't save it anywhere, it just won't be used later in the main. Okay. Cool. So in this case, we said, what is the output? The sum is just going to be 4 because all this work we did to get the number 6, we didn't store anywhere. So at the end of the day, the sum in the main function is still 4. Cool. All right, runtime of line 6. So before we answer it, runtime is related to a certain kind of input and essentially how many elements we're processing. So in this case, for this function, what is our input?
Nums?
Yeah, it's like this vector of nums. And so what would represent n? Like n is generally how many elements we're processing. So what? Yeah, 3 in this specific example, but how did we get it? Like if we were to generalize. Not index, close though. Yeah, it's essentially this nums.size. Like if we had 1,000,000 elements in this vector, how many times would this line 8 run? 1,000,000 times. If nums.size was 100, how many times would this run? 100. So it's like directly proportional to n, the stuff in the for loop. Does that make sense? Okay. So I guess, first off, this line 6, double sum equals 0. Does it matter how big the vector is for how many times this code runs? No. So what do we call that in terms of big O notation? O of 1. It's constant time. It doesn't matter if n is 100 or 1,000,000. Line 6 is always just going to run one time. We kind of said the answer for 7 through 9. Based on n, how many times does line 7 through 9 run? Essentially n times, right? If size is 1,000,000, this will run 1,000,000 times. So what would the big O notation of 7 through 9 be? O of n. Cool. And then for the runtime of the overall function, we essentially look at each of the code blocks. So we said line 6 runs in O of 1, 7 through 9 runs in O of n, line 10 runs in O of 1. So is our answer then O of n plus 2 times O of 1? No. What does it end up being? Just O of n. The reason being that as n gets really large, like if n is 1,000,000, there's no difference in the runtime whether this runs 1,000,000 times or 1,000,002 times. So we can drop those like 2 constants. Yeah. Yeah. Like as n gets big, the constants don't matter anymore. We get like if there were 1,000,000,000,000 elements in this like vector, the runtime difference between 1,000,000,000,000 versus 1,000,002,000,000 is like it doesn't matter. It's negligible. So we just drop like the lower values. Generally like the ordering goes like, it's like the earlier class was doing big O too. It goes like O of 1 is the smallest, then O of log n, then O of n, and then O of n squared. And so we take like the slowest time. In this case, because this problem had O of n and O of 1, we just say the overall runtime is O of n because this dominates.
So when do you use O of log n?
O of log n is if the problem space gets divided in half each time the loop runs.
So for like using that example, the 50 and 25.
Yeah, that one. So that's like binary search. That one has like a loop in it. Most loops are usually O of n. Like this is like an O of n loop. But binary search is O of log n because even though we have a loop, the problem gets smaller by half each time.
We would use O of n squared if inside that for loop was an if statement.
Not an if statement if there is another for loop. Yeah. Because then like whatever's inside both for loops would run n times n times. Okay. Yeah, I would even encourage you to like put that down on the note card. That's generally the ordering. And so if your function has multiple of those, you just take whatever's the like slowest. Cool. All right. Any questions here?
So, what's O log n?
That's the one where the problem gets split in half each time. So if we had like a for loop, like on Monday we did the example where I started at 64, each time we divided by 2. So we print out like 64, 32, 16, 8, 4, 2, and then it stops. That would be like log event. Or an example would be like binary search, where you're trying to guess a number between 1 and 100. Your first guess would be 50. I tell you it's less than that. Then you guess 25. Then like 36. Like you keep narrowing it in half each time.
What would be selective sort?
Selection sort, that's like nested for loops. So that one would be O event squared. There's a homework problem, I think in homework 9, like the last problem in homework 9 has more examples with runtime analysis. So if you want more practice with it, I'd encourage that you do that problem. Okay. Cool. All right, final logistics. Everyone in the 1 p.m. lecture. So your final is going to be 4 p.m. to 6 p.m., Monday, December 5th. Kadir, you're okay attending this one, right? Cool. All right, I'll check with Sydney the later one. Okay, and if you're in the other lecture, is anyone here normally in the other lecture? Yeah, Matthew, EJ, Aaron. Yours is going to be Tuesday, December 6th, 1 o'clock to 3 o'clock. Okay, Will?
Could you repeat if you're in this lecture,
If you're officially enrolled in this one, this is going to be your finals time. You won't have any class conflicts. Like this is the Morehouse schedule. Final is going to be in this room. Make sure you come on time. That way you have all the time available to you. Yeah. All right. Final exam topics. Again, grab a note card if you don't have a note card. For the coding portion, we still have 7 minutes. Hold up. For the coding portion, it's going to look almost identical to homework 8 or homework 11. So I'm going to have you write different functions. I'm trying to think of some game. Right now I'm leaning maybe some modified version of Deal or No Deal. I'm going to have you create different functions for the game. And then the final part is going to be you calling those functions and like writing out the code for it. Okay? So written part will be similar to what we did today, maybe a little bit longer. Coding part will be very similar to homework 8 or homework 11. If you haven't finished any assignments, make sure you finish it by December 4th. I'd especially prioritize these two. Book an appointment. So I think the paper's going around. If you want to do an in-person one, you can do it with me today in person. Otherwise, make sure you book an appointment with a Googler. Has to be done this week. If you need to cancel the appointment, actually like physically cancel it in the email so the Googler's not waiting for you.
And where is the thing for in person?
Just in my office hours. Yeah. Okay. I just have 3 slides here on my last thoughts. I guess in terms of highlights, it's been really cool for me to see like students sharing how they see code in real life. So like students that are playing video games, they're like, I now see like this part of the game has an if statement here, or this part has a loop. And it's really cool for me to see students like essentially thinking like a software engineer. It's cool for me as well to see like students solving hard problems, and especially like when you get that check mark and you do solve it, like seeing that kind of moment of joy and realizing that you are capable of doing it. That has been probably the most rewarding part for me. For the first time in my life, I actually like wake up before my alarm clock on Monday, Wednesdays, and Fridays. Like I genuinely have enjoyed coming in and working with you all. And I think part of it is you all are very attentive and have given a lot as well in terms of back and forth. Like I don't think there's a single time where I asked a question and I was just like left hanging. And that was kind of a big fear coming in. So I appreciate all of your participation and effort. A little sad at first, but then realized it's a good thing that students were able to beat my Strategic Sevens player strategy. Like I gave it my best shot, and it's cool to see that students are at that level and are able to beat what I'm able to do. And then the final part is being a part of this classroom community. It's cool for me to see like the camaraderie that was made between you all, like being able to help each other out, giving each other fist bumps. Yeah, it's been like a really special semester for me, and I've really enjoyed it. So thank you all for making it special. Definitely show that I do want to do some teaching stuff in the future. So yeah.
What was your part about?
What?
What was your percentage?
So we're running everything, but yeah, well, students were able to beat when we ran it head to head. Yeah. Okay, connect with me. Best way to stay in contact is with email. If you're like applying for any internships or want to do any mock interviews in the future, you can always send me an email. Or if you just want to send a life update based on what you're up to, I'd love to hear what you all are doing in the future. My next couple years plan, I just signed a new offer for a team in New York, like an education team, so I'll be going there for a couple years. And then I'm hoping to apply for this GIR program again when most of you are seniors. Try to come back and teach the intro class again and hopefully see some of you on campus. But it's kind of a competitive program, so we'll see. Fingers crossed. One final observation. This is my last slide here. I was trying to think like what I'd put as my final thing. And at first it was going to be something a little bit cheesy, like believe in yourself. But I feel like you all already know that. And I think you know that you are capable of computer science. So I was trying to think of what would be like my most honest feedback or piece of advice. And I came down to this. Your CS classes and general classes in college at Morehouse will teach you how to think like a software engineer or whatever field you want to go into. But to actually like become an engineer, you need to practice and build your own stuff. And concretely, what that looks like is make sure you attend your labs, finish assignments. I would say like some students come just for the 3 lectures, but don't come for the labs. I would argue it's almost better to come for like 2 of the lectures and 1 of the labs. Like ideally you come for everything, but if you had to prioritize, because if you don't actually practice these skills, it's not gonna stick. And so you have to constantly be coding, constantly be trying stuff, because that's where you know where you stand. Try to teach others to code. I think I've become way, way, way better at C++ this semester because I've had to actually teach it and I've had to actually like read the textbook and understand what's going on. So I'd encourage you to try to teach others as much as possible. Participate in hackathons. Morehouse attends a lot of hackathons. Try to join some of those teams. And finally, build your own project, website, like anything. Even games, like when we play Hacksball, you don't have to know how to code everything, but try coding like little parts that you do know. Like just mess around with things, play with things. That's what's going to make you a software engineer if that's what you want to do in the future. Okay? Cool. That's all I have. Make sure you book the appointments. There's an extra credit opportunity on EdSTEM. Even if you don't need extra credit, please still finish it. It's just like a final survey. It'll add 5 points to your final exam, which is pretty significant grade-wise. Should only take about 15 to 20 minutes total to complete. So please make sure you do that, and it helps me to get feedback on how the class went. Cool. Thanks, everyone. Really appreciate it. Yep.
You got my email, right?
Email